Good morning students, class 11th. Today I am going to start the next unit of chemistry, redox reaction. In volume 2nd, you will find this chapter, redox reaction. What do you mean by redox reaction? Redox reaction can be defined as the reaction which involves reduction as well as oxidation. Redox means the reactions which involves reduction as well as oxidation reaction. Such type of reactions are termed as redox reaction. So where there is oxidation, there is always reduction also. Hence, such type of reactions are commonly termed as redox reaction. Next is, how can we define the redox reaction? Means reduction oxidation. Different ideas were given to explain this concept of oxidation reduction. First is the classical concept of redox reaction. How can we define reduction and oxidation according to this classical concept? So, according to classical concept, oxidation may be defined as a process which involves addition of oxygen or addition of any electronegative element. Remind it, the process which involves addition of oxygen or addition of electronegative element or which involves removal of hydrogen or loss of hydrogen or removal of any electropositive radical or element. We can write a radical or we can write as element. More precisely, we can use the word radical. So, oxidation may be defined as a process which involves addition of oxygen or electronegative radical or loss or removal of hydrogen or electropositive radical. For example, if we have taken example of ferrous chloride FeCl2, if it undergo further addition of Cl2, then the required product formed will be termed as FeCl3. This is termed as FeCl3. Now in this spaces, reactant side we have FeCl2 and here it will changes into FeCl3. How this change takes place? This change takes place by addition of this element. This element we know that is electronegative. So this radical or this element is electronegative. That's why addition of this electronegative element shows that this ferrous chloride undergo oxidation. Clear? This is example of oxidation reaction. Next is reduction. Second example is reduction. It is just opposite of oxidation, the process or the reaction which involves addition of hydrogen or electropositive radical, or which involves loss of oxygen or any electronegative radical is termed as reduction. Suppose we have taken example of bromine when combines with hydrogen sulfide. What happens? This H2S changes into HBr and S. Clear? This bromine and this H combines together to form HBr and this H2S changes to S. Then how can we write it? This Br changes into HBr. It means this Br molecule here added hydrogen, therefore this will undergo reduction. And this H2S changes to right side or product side into S, therefore this S is formed by loss of hydrogen. It means this process is oxidation. These two processes takes place side by side. If one species is reduced, other will be 100% oxidized. If the reaction is redox reaction. If the reaction is not redox, it means these two processes will not take place simultaneously and the reaction will further not considered to be the redox reaction. Clear? Now next term is, what are oxidizing agent and reducing agent? How can we differentiate between these two terms? What do you mean by oxidizing and reducing agent? Oxidizing agents are also termed as oxidants. They are also termed as oxidant, and reducing agents are called as reductant. Clear? Now, oxidizing agent is a substance which supplies oxygen or any other electronegative element. So, oxidizing agent or oxidant is that substance which supplies oxygen or electronegative element and removes hydrogen or electropositive element. So oxidizing agent after oxidation, second definition, or we can also define it as oxidizing agent after oxidation itself reduced, which reduces itself and oxidizes other. Such type of agents are called as oxidizing agent. Clear? Which oxidizes other species and reduces itself is termed as oxidizing agent. For example, we have a reaction here. Hydrogen sulfide, when combines with chlorine, it forms HCl with sulfur. Clear? Now first of all we will check whether which species undergo oxidation and reduction. This H2S changes into S by loss of hydrogen. Therefore, this process is termed as oxidation, and this Cl2 changes into HCl by addition of hydrogen. Therefore, this process is termed as reduction. Now, the species which undergo oxidation or which is oxidized will act as reducing agent, and the species which is reduced will act as oxidizing agent. Now, how can we define oxidizing agent? The agent which reduces itself and oxidize the other, means this Cl2 reduces itself, changes into HCl, and it will oxidize this H2S by removing hydrogen and changes it into sulfur. Clear? So the species of the substance which undergo oxidation will act as reducing agent, and which undergo reduction will act as oxidizing agent. Second, what are reducing agent? Reducing agents or reductants are the substances which supplies hydrogen or electropositive element and removes oxygen or electronegative element. These two terms are just opposite to each other. Or we can say that reducing agent is a substance which after reduction or after carrying out reduction itself oxidize and reduces others. जो सब्सटेंस खुद क्या हो जाएगा reduce and खुद हो जाएगा oxidize and reduces the other. Such type of substance are called as reducing agents. Clear? Next is other definition of oxidation reduction in terms of electron transfer concept. This is the classical concept. Second is electron transfer concept. On the basis of this concept, we can define oxidation and reduction as the process which involves loss of electron is termed as oxidation, and the process which shows gain of electron is termed as reduction. Or more simply, we can remind it as oil rig. OIL. O means oxidation, I stands for is, L means loss, means oxidation is loss, reduction is gain. Clear? Oxidation is loss of electron and reduction is the gain of electron. This is the definition of oxidation reduction in terms of electron transfer concept. We can also explain it as, example is, suppose we have taken magnesium and changes into Mg2 positive by loss of 2 electron. Now in this reaction, magnesium consists of 12 electrons, and by loss of 2 electron, now magnesium have only 10 electrons. Therefore, this magnesium metal undergo loss of electron. It means this process is termed as oxidation. Therefore, loss of electron always results in increase in positive charge. Clear? Here the charge is 0 and here charge is 2 positive. Where there is increase in positive charge, it means the process is oxidation. Second, loss of electron also results in decrease in negative charge. First point is loss of electron causes increase in positive charge. Second example is loss of electron results in decrease in negative charge, as suppose we have taken MnO4 negative ion, 2 negative ion, it will changes into MnO4 negative by loss of 1 electron. So here charge is -2 and here charge is -1. Therefore, decrease in negative charge takes place. Therefore, this process is again said to be oxidation. Got it? Next is reduction. Example, suppose we have taken Fe3 positive. By gain of 1 electron, it will changes into Fe2 positive. Now first criteria to identify reduction oxidation, we have done the criteria of oxidation. Now next, how can we identify reduction in terms of electron transfer concept? First point is gain of electron results in decrease in positive charge. Here the charge is +3 and here the charge is +2. So here decrease in positive charge takes place. Therefore, the process is said to be reduction. Clear? Fe3 positive plus electron gives Fe2 positive, because we know that Fe3 positive consists of 23 electron. By gaining 1 electron, it becomes 24. So here gain of electron takes place. Gain of electron in case of positive charge spaces shows decrease in positive charge is termed as reduction. And secondly, gain of electron results in increase in negative charge. Second point, gain of electron results in increase in negative charge is termed as reduction. It is totally just opposite of oxidation. So example is Cl2. By gaining 2 electron, it will changes into 2Cl negative. Here the charge is 0 because this species is present in its elementary state, and here the charge is -1. So increase in negative charge takes place. Therefore, this process is again said to be reduction. Got it? Now we have you should remember 2 points here. If the species carries positive charge and positive charge increases, the process is oxidation, and decrease in negative charge again indicate oxidation. Decrease in positive charge or increase in negative charge indicate reduction. Clear? So from these complementary results, we can say that oxidation reductions reactions are complementary. It means these two reactions always takes place side by side. For example, we have taken HgCl2. This is called as mercurous chloride. When combines with SnCl2, it gives Hg2Cl2 plus SnCl4. Now oxidation state of mercury in this compound is 2. Stannous tin in this case is oxidation state is 2. We use Roman numerals here. Oxidation state of mercury here is 1 and tin here is 4. So now can we easily check which species is showing reduction and which species is showing oxidation. Here oxidation state of mercury is 2 positive and here it is 1 positive. Decrease in positive charge, it means this process is said to be reduction. Clear? Sn here is 2 positive and it is 4 positive. Increase in positive charge, it means this process is oxidation. So these oxidation reduction reactions are complementary to each other. They always takes place side by side. Next is oxidation reduction in terms of increase or decrease in oxidation number. Before discussing the third concept of oxidation reduction in terms of increase or decrease in oxidation number, I am going to explain some other examples of oxidation reduction reaction in terms of electron transfer concept. Suppose we have taken Na when combines with chlorine, resulting in formation of NaCl. The physical state of sodium is solid, chlorine is gas, and the salt formed is ionic solid state. On balancing the equation, this equation is obtained. Now in terms of electron transfer concept, it was observed that this compound formed is ionic, having 1 positive charge on sodium and 1 negative charge on Cl. Now this sodium here changes into Na positive and this Cl2 changes into Cl negative. Now this sodium changes into Na positive. Now increase in positive charge takes place. Therefore this process is oxidation, or we can say that loss of electrons takes place. 1 sodium loses 1 electron and 2 sodium atoms undergo loss of 2 electrons. Therefore this process is oxidation. This Cl2 changes into Cl negative. It means it will gain 1 electron because negative charge increases. If the increase in negative charge takes place, then the process is said to be reduction. Here charge is 0 and here charge is 1 negative. This is 1 negative for 1 Cl and 2 electrons are gained for 2 Cl negative. Therefore, in this case, gain of 2 electrons takes place. Therefore, the process is said to be reduction. Hence, we can define oxidation reduction in terms of electron concept as clear. Revise your solved problem or unsolved problem of oxidation reduction in terms of gain or loss of hydrogen, in terms of gain or loss of electrons, including the concept of oxidizing and reducing agents.